Okay, hello everyone. Thank you for attending the Python workshop, everybody here. So we're going to get started. Okay, so please go to your computer and open Spider. Okay, it's on the desktop, and so that's going to be useful for what we're doing today. Spider is a computer program which allows you to write Python code. Now, what does that mean? So, Python, this is very odd, I gotta say, this is very strange. Would you like to, oh, never mind, it's okay, I'll just pretend like this. So, Python is a language, basically, that allows us to speak to the computer. Okay, so it's valuable. It's useful to be able to talk to the computer, because computers they're pretty dumb, but they're smart in the way that they can do things very quickly and with a very high precision. So a computer is not going to make an arithmetic error for the most part. It's not going to multiply two numbers wrong, and it's going to do what you want it to do very quickly. Sorry, there's no food allowed in here. So, we can use the computer to do math and other operations for us very quickly. And this is very useful. But the problem is that the computer speaks in binary. And so if we want to give it instructions, we would typically have to tell it how to do this in a very abstract, way which cannot be clearly understood. So instead, we can use a programming language like Python to tell it what to do. And so Spider allows us to do that. This is a program called an Integrated Development Environment, an IDE, which allows us to essentially talk to, write and interact with Python, and therefore tell the computer what we want it to do. So if you open up the program, let me just switch the window here. Okay, here we go. So if you open up, I'll get rid of the logo. So if you open up the program here, you can see two panes, okay? So on the left, this is what's called the development environment, or this is where we are going to write our code. It may not be called the development environment. The actual name of it is not very important. But we'll get to this part on the left later, so I'm just going to make it smaller. On the right, this is really the core. This is the console. Okay, so what's happening here is that we can speak to Python, and we can tell it what to do. And Python, when we give an instruction to the computer in that language, the computer will interpret it, and then it will spit out an output. And so that's what's happening in the console. Right now, we can see our cursor is blinking here. The computer is ready for an input. We are just going to type into the console, and then there will be an output. So let's say, for example, I want to type "Hello, computer." Now, what's happened here? It gives an error to "Hello, computer" because it doesn't like the way that this is input. So, in order to interact with the computer through the Python console, we have to do it in the Python style, and that is the Python language. So the whole art of all that we're trying to do here is to learn any command that we want to do, learn how to phrase it in the Python language, and then tell the computer how to do that thing. So we're going to get started with some basic elements. How does Python work? How are you supposed to interact with it to instruct the computer on what to do? So the most basic thing in Python is an object. What is an object? An object is it's kind of abstract in terms of how it is stored in the memory, but all you really need to think about most of the time is that an object is some segment of memory, it's some piece of information which is being used for some purpose and which we can act on, okay? There are a few types of objects. So we can, for example, to learn, I'll say this. So the most common object types in Python, there's a number, okay? So we put in the number 5 and it puts out the number 5. Why is this? We'll get to that in a moment. But so we can see that it doesn't give us an error when we put in just a number. Okay, what if we want a decimal? It doesn't mind that either. So these are two object types. So Python, it likes just numbers, integers essentially, and it doesn't dislike decimal numbers. We can use this command here, and I'll explain more in a second what is this actually doing. But we can use this thing called type to tell us what is the type of whatever we put in the brackets. In this case, the type of a 5 is an integer, and the type of 5.5 is a float. Float stands for floating point number, which has to do, the name floating point number has to do with how Python is storing this decimal in the memory, but it's not very important for our purposes. So we have now, essentially with these two things, we're fully set on storing any sort of number we would want to store. There are some more different ways to store numbers, but at the basic level, you could do anything you wanted just with this. What are some other things we might want to store? Well, we might want to store a string, like a series of letters. To do this in Python, the instruction you give to the computer is you put it in quotation marks. So let's say, hello world. Well, it doesn't have an issue with that. It also puts it out. So we can sort of see a pattern here. Whenever we put an object, just an object, into the console with nothing else, it'll just spit it back out at us. And this will be, the reason for this is useful, we'll see down the road here. But so it doesn't mind just strings of letters as long as we put them in quotation marks. What does it call that? This is a str. As I said, it's a string of letters or some sort of a word or something. Then there are two other types. So the next one, which we might find to be useful, is computers. They work on switches. Inside it's just a bunch of, I don't understand how much it works, but it's just a bunch of switches going on and off. Computers work in binary, and so it's useful when we're dealing with computers to want to refer to true or false values, a 0 or a 1. So if we want to say what is true, when we use that true, notice if I do this, it doesn't like it. But if I use a capital T, true, it likes that, it accepts that as an object. So true is an object, and it isn't any of these other ones. If we look at type true, it's a type bool, which really sounds like nonsense, but it has to go back to this guy. I think there was some mathematician who had worked out some way of doing algebra with true or false values. George Boole, pardon? I don't know. I'm not very familiar with the history, but I mean it's named after George Boole. So, anyways. Yeah, so actually, yeah, so George Boole did stuff before computers were invented. I mean, that there may be some analog computers somebody made, but like, before modern computers were invented. Which is interesting that, you wouldn't have thought it would be that important, but now it's pretty valuable stuff. So also, like we're talking about true or false values, so we have a type true. If we type false, that's also a bool. So we have here 4 different ways of representing information in Python. We have true or false values, we have words, and we have 2 different ways of representing numbers. So this is all good, but notice, we don't have any sort of object. All that objects hold, as of now, are, some piece of information. We would like for there to be potentially something that we might be interested in doing is storing objects inside of other objects. Now, the simplest type of object that can do this is called a list. And the instruction to Python that you give to make a list is square brackets, okay? So let's say we had a square brackets list. And the first element in the list was a true bool object. Okay, the second item was a string, a word basically. And then the third item is a number. Okay? As I said, it prints it back out, which is the behavior we want, or the behavior Python gives when you just put an object into the console. And then if we do console, that's the word I just said. If we do type, and then I'm just going to make an empty list, but it's the same thing, type list. Okay, so this is the most basic element in Python, is just different object types. And, this is very basic. I'm really belaboring the point here, but in my experience, like 60% of the time when you write a code and it's bugging somehow, it's because you don't exactly understand the object type that you're dealing with. Maybe you know what it is, but you don't understand exactly how it works or what it's for, or something else. So it's very good. It's very useful to understand. What are the object types you're working with. So we're going to see there are many more object types than just these in Python. These are only the basic ones, but this is what you need to know. So, okay. Next, so far, every time we've wanted to talk about or reference an object, I've had to type it manually into the console. We can see, it might be useful, obviously, we want to refer to these things, save it to memory, not just have it in memory and then, have it released, but save it to memory and then refer to it later. So for this, we do a variable. A variable is essentially just a label for some piece of memory. So we have our object, like I've said, an object is just some piece of memory sitting in the computer somewhere, and a label, or a variable, is just some other thing which we have, which refers to that piece of memory. How do you define a variable? It's very simple. You just do, let's say, var is our name for the variable, okay? Var, and then you do an equal sign, and then some object. Notice here there's been an ambiguity in how I'm typing my strings. I've been typing them with both single and double quotation marks. There is no difference. There's some difference, like if you do a double quotation marks, you can put a single quotation mark in your word, but apart from that, there's no difference. The Python doesn't care. Okay, so now I'm typing in var equals hello world, and now we don't get any output. So notice this is another thing. When you just put a command into the console, not the name of an object, not something which will have an output, just a command, there is no output. Okay. So now we type var and then press enter. We're going to expect exactly what we get back when we just put in hello world. So now, for all intents and purposes, going forward, in this case, this isn't necessarily true 100% of the time, but in this case, whenever we type var, it's as if we were typing the thing it refers to. They're basically, for our purposes, they can be thought of as the same thing. That isn't exactly true, of course, in Python memory. They're literally not the same thing. They're different letters being used to refer to each other. But in this case, they can be thought of similarly. So I have an exercise here. Okay, I have an exercise. So we can have you guys do this. I have just typed the exercise into the console. Define 3 variables which refer to integers, then define a new variable, or define a new variable number to be a list. Oh, no, I see. Define a new variable numbers to be a list containing A, B, and C. How could we do this? Well, like I said, perhaps we could just use the principle that the variable refers to the object. How did I refer to objects inside a list here? How can that be used to assign these variables in a list object? Then find the value of numbers by typing it into the console, like we said. What do you find? Does anybody actually? No? Okay, so pause the video now and do the exercise, and then unpause once you're finished. And what you will find is that the list will pop out, and let's say our numbers were 1, 2, and 3. It will be this output, even when you just type in numbers. So notice that the variables you originally used, when you put them into the list, it will just be the objects they referred to being stored in the list when you output the value of the list, okay? So the variable, very rarely in Python will the name of the variable get outputted. It's pretty much always the thing it refers to if you're outputting the value of the variable. Okay, so this is all very good. So we know how to save, essentially we know how to represent different data in Python, and we know how to refer and save that data to be referred to later. Okay, so this is all good. Some miscellaneous stuff which is good to know. How can we have these variables operate on each other? So a useful one, if we want to multiply 2 numbers, it's an asterisk symbol. So this works for both integers. You can see an integer times an integer is an integer. And for floating point numbers, this 3 point is just a way of telling the computer to make it a decimal. That outputs a floating point number. So that's very easy to see. Okay, so single asterisk is a multiplication. Double, so if like say we wanted to do exponents, say we wanted to do 4 squared. So that you can see is not the right answer. 4 squared is not 6. Did you know that, Ivan?
Yeah.
How can we do 4 to the power of 2? It's actually double asterisk. Okay, so this is something that's good to know. 4 squared, in fact, is 16. Okay, so if we want to do exponents, it's double asterisks. Okay, and similarly, there's no divide sign on a keyboard, so the symbol for division is a slash. And then there's this other operator called a modulo, which is good to know. So what it does is it divides 2 numbers and then rounds down to the nearest number. Actually, I haven't used modulo in a while. I might be misremembering. No, that does look like what it does, yes. So let's say we had, okay, this was 5.5 divided, or mod 6.1. Obviously that's less than 1. It's a fraction. It's like 0.8 or something. And then it gets rounded down. Whereas if we did 6.1 mod 5.3, then it's 1. So this seems kind of useless, but it's actually quite useful. We'll see an example later. If you want to detect whether a number is a integer, if you want to detect whether a number is an even or an odd number, this is very useful. So these are just things that are good to know. Another thing that's good to know, before we get into some of the more structural things which we can use to give commands to the computer with Python. A comment. So a comment starts with this. A comment happens in Python when you type a hash, and then whatever happens after. And notice there was no output here. Now, anything else I type in Python, pretty much pretty much every console input that you could imagine will give an error. There's a very few number of things that Python will accept and not take an error, right? But when you put a slash or a hash at the beginning, anything can be accepted. And so what is this? This is called a comment. So if you put a hashtag at the beginning of your line, it will disregard the entire line. It won't care. And this is useful when we're writing scripts, which we'll get to later. You can put a comment and then explain what your code is doing to yourself and to others if you're sharing the code with other people. And then it's less confusing, and then that comment won't interfere with your program. Finally, one more thing which I would like to point out is, let's say we have a variable number and we're going to assign it to the value 6, okay? Let's say I wanted to add 1 to number. Okay, we would write number equals, okay, well, what's number plus 1? So what we're going to do here, it's kind of odd, but this is sort of how the variable assignment works in Python, is you write number equal number plus 1. Okay? This is a very odd thing, but essentially what Python is doing when it looks at this line of code is it looks at, okay, number equal, and then it says, okay, as of the end of this line of, when this is executed, I'm going to set number to whatever this value is. But it doesn't execute the code until the entire line is read and processed. So then it looks at the rest of the line, and it kind of doesn't forget, but it kind of ignores what happened up to that point, and it says, okay, number is equal to whatever this is. What is this? Number plus 1. And as of this point, number still has the value 6. So if we run this, and we put number back into the console, it'll be 7. So it's kind of gobbledygook, this isn't a mathematically correct term. Number is not equal to number plus 1. That's just how Python variable assignment works, okay? But we end up wanting to add some number to a variable so often that we have a special way of writing it, which is number plus equals to 1. And then if we look at number again, it's 8. So there is no difference between line 28 and line 30 here. They're the exact same thing. Number plus equals 1 is exactly the same as number equals number plus 1. It's just that you end up adding numbers to variables so often. This is a special thing. Okay, so that's all good. Let me just clear the console here so that I can refer to, because each time you type in the console, it numbers the line, and I want to be able to refer to the number. So that's at a basic level. That's all that we're concerned with in Python. Okay, I'm just going to readjust here and take a seat. Do we have anybody in the chat? Anybody online? One person. Chat is disabled. Oh no. Wait a second. Oh shoot. Chat is disabled. What an error. This is tragic. Okay, Please, if you're in chat, message me on Discord, okay? And I will answer your question, okay? I apologize. I didn't intend to turn the chat off. Should be fine now. It's only one person, so. Okay. Okay, we're continuing on here. So, we have basically a pretty good understanding at this point of how we can represent different data in Python and how we can refer to it. But what do we, if we want to actually operate on an object, what can we do? Well, there are these things called functions. Okay, so like in regular math, a function is basically something that takes in an argument and then outputs something else based on that argument. Okay? So, let's say we wanted to, as before, find the type of an object. This is a function. So the type operator, or whatever I called it before, this is nothing else than a function in Python. It is a function that's built into the language. You call type, and then in the parentheses, you put the argument of the function in, and then it returns an output. So in fact, you can think about it almost like if you just type a number, or type nothing into the console, like just around an object, just type in an object with no function call around it, that's almost like a function call itself, and it'll just output the function. Or sorry, output whatever you put in. That's kind of like, if you know in math, it's kind of like the identity operator, just putting something in to the console. So, what are some other functions? Okay, well, so what else might we want to know? Let's say we wanted to know the length of a string. Okay, then there's the len function. Okay, so let's say, what is the length? We've been talking about this hello world string. It's a great classic. Apparently there's 12 characters. Now notice, this includes the space. Okay, so it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then there's one exclamation mark and one space. So spaces are included in the length of a string. Let's say, what's another one? The absolute value of a number. Okay, that's just abs, it's nothing else. Abs of -5 is 5. That's obviously true, and this is no different than the mathematical function abs. Okay, so many functions in Python are literally just math functions which we're using in Python now, and there's a slightly different syntax than we would normally use, but that's just because of the limitations of having to type these things on a classic typewriter style keyboard. Okay, one more, and now for this we're going to go over to the separate environment. So there's another function here called print, which is very useful, but it's not immediately obvious why when we're in the console. Okay, so if we write print hello world, it prints hello world. Now no, it doesn't say out 3 or whatever. It doesn't say out 4 hello world. It just writes hello world here. So there is something going on here. Print hello world. But to truly understand why is the print function so useful, and usually, often Python, a Python tutorial or a computer programming tutorial will start with this. It'll start by outputting some set of characters, often typically hello world, onto the console. But the print function is much more useful than just that, because let's go over here. So what is this? What is this thing that we've been neglecting here on the left the whole time? So, as so far, we've been inputting our commands one by one into Python. And this is useful. I mean, essentially what we have so far is a calculator, which is pretty good. A calculator which also knows what a word is and which can store, lists of things. Now that is pretty good. I mean, especially like, let's say calculators didn't exist, handheld ones. This would be pretty good. But Python is much more powerful than that because this thing on the left lets us write what is called a Python script or a Python program, a .py file. And what happens when we run, when Python runs a Python script, is that everything we have written here, forget about what this stuff is, not important. Oh, you can see here, it's just comments, like it's just commenting stuff at the top. This triple exclamation mark, or sorry, triple quotation mark sign is just another way of writing a comment. It's not very important. So this on the left here will just let us write a series of commands which we want to give to Python, and then when we run the Python script, it will execute them all in order, and it will do it very quickly. So let's say we had some calculation, some big long calculation. We didn't want to type in every line manually. We could type them in a Python script and then have it queue up and run them all in order. Okay? So, like what does this mean? Let's say we had some variable. Let's go back to the old example. So we had a, the exercise we had before. A equals 1. Notice I press enter. It doesn't get put to the console. There is no console from the Python script. In this IDE, in the IDE which is in the computer lab, computers, this is called Spider, there's a green triangle button here, a run file button. So that's what we're going to press. Essentially, that's the equivalent of pressing enter on the console, okay? So let's go back to our old example. 3 equals C. No, C equals 3, and then we're going to say numbers is equals to 1, 2, 3. And now, okay, first of all, what happens? I'm going to run this. It says, okay, so it's telling us in the console we've run the file. That's all good. And then if I type in numbers, it's outputting 1, 2, 3. Okay, so, oh, sorry, the example technically was this. Oh, shoot. No, this. Yes. 1, 2, 3. Very good. But that doesn't happen automatically when we run. Well, you might say that's because I haven't given it the instruction. But even if I put numbers here, typically if this command was inputted into the console, we would output numbers, right? That's what I just did. But that is not the case in a Python script. So there is one difference, which is that this, idea of a identity function, where you just get out the value, that is only a case in the console. It does, if you just put in an object as a command in the Python script, it does not get outputted in the console. What do we need to do in our Python program if we want to print out some object? Say, the status of a calculation which we were doing, we have to say print numbers, and then numbers gets printed. So this is very useful. So, that's all good to know. It's very important to understand how can we use the Python script window and how is it different from the console. And we'll come back to that in a moment. There are a couple more types of functions I want to discuss here. So, the first one is called indexing. Okay, so we have before here numbers. That's a list. Now, a list will have different elements. Okay. So, just making sure you guys can see this. Oh, it's a little cut off. Okay, I'll go back to like this. Is that good? Yes, that's perfect. So, let's say we wanted to access just the second element of numbers, okay? We would say, for example, there's something called, we might want to do, number 2, okay? Numbers 2. And what I've done here is called indexing. This is a special syntax. This is another use of the square brackets, where if you put the square brackets at the end of some object which has some sense of a length or a set of elements, you can use the square brackets to refer to an element in numbers or in any list. Or, for that matter, a string can also be indexed. Okay, and let's see what this gives. Now this is weird though. So it's putting in 3. Notice I said the second number, I put in 2. So actually indexing, because it's weird, because it's computer scientists made this, it's indexing starts at 0. There's not really a good reason why, except for just the fact that binary operations, you know, it's 0 and then it's 1. So, you know, things in computer science start at 0. There's not really a good reason why. But if we want to access the first element, we do numbers at 0, and that gives us the first element of the list, and then so on. So the second element of the list has the label 2, or sorry, it would have the label 1 in indexing, and so on and so forth. So I will draw a diagram here. Say we had some list. And this we had set equal to, I'll stop using, perhaps it's confusing to use numbers. This looks good. Here, I'll set it on the full camera for this. Okay, so let's just go away from the regular method for typing Python objects. So A, B, C, like we had done before, assuming that these things each are a variable which refer to an object. The index, which refers to an element in this list, we can have 0, 1, and 2, and then so on and so forth. And again, the way to refer to that is square brackets. So it's another use of those square brackets. So we just put them after the list, and then let's say here list at 0, that will be equal to, now notice this here isn't a Python equal sign, because we're not assigning the variable. We don't want to, I'm not trying to assign the variable list 0 to something new. I'm just writing that these things are equal. List 0 will refer to A. Maybe I'll put it that way. It's an arrow. List at 0 will refer to A. And I mean, there's no really good way to know, like, why does the square brackets in one case refer to a list object type? Why does it in the other case refer to, you know, indexing? It's not really clear. You kind of just have to learn how to speak the Python language. This is like, you know, it's like a real language. If you want to learn how to speak it, if you want to learn how to use it, you kind of just have to learn the rules. There's no really good way to get around that. So it's just unfortunate. But I would think you'll find, you know, the Python way of speaking is pretty simple, so it's not too tough to learn. Let's say we had a string also. I mentioned that we can index over strings. Hello world. What is the 8th element of hello world? Well, notice again, okay, so we start at 0, so the 8th element is index 7. Apparently the 8th element in hello world, the string, the 8th character, is the letter O. Which I suppose makes sense. It's the O after the W. Okay, so this is all very good. Now we can also do what's called slicing, which is essentially indexing, except instead of referring to just a single element, it refers to a subgroup of whatever object. And now notice, so I will want to point out one thing. I suppose I'll finish with the example of slicing here. So if we wanted to refer to, let's go from the 5th to the 8th element, we do a colon in our index square bracket box, and then we will type another number. Okay, so there we go. Hello world 5 to 8. Oh, is that a semicolon? I can't really see on my screen. There we go. And that's space WO. Now notice though I said 5 to 8, and so this is starting at the 5th and going until the 7th index, the O here. But it isn't including the 8th character. Or sorry, the character at index 8. This is, again, just something you have to learn how to do. So when you do the slicing, it starts at the 5th, or it starts at the first number, let's say start, and it will go up to the end, but it won't include this ending value. This ends up being a little bit easier to work with later on. It's just something you have to learn. Anyway, so that's very useful to know. Okay. So using this, I have another exercise. Oh, well, there was one other thing I wanted to point out, which is that let's say we have 5, the integer 5, and then we try to index like the 4th element, i.e. the 3rd index. Would we want, like, what is this, what do we expect? You know, this doesn't really make sense as a thing to ask Python to do, so it doesn't really make sense here. And predictably, Python gives an error. So that's just what it is. I mean, you can't do slicing on things which don't have some sense of a collection of elements, and that makes sense. So there's one more thing here, which I wanted to touch on. So in the theme of functions, we had functions on object types. So let's say we had the list here, we had the list numbers. So we wanted to add something to that list. We could do numbers.append. And now what is this that I've just written here? So every time before this we've called a function. We've done, like, we would do, you know, append and then the object, okay? But there are some special types of functions which are called methods. And what these do is they are called in this way, where you type the object you want to operate on, and then you do a dot, and then you do the operation. And this is the function call, okay? So instead of calling the function and then giving the object you want to operate on, or giving the function, giving the object you want to, you know, work with in the call, you're actually, it's kind of like the object in this case is part of the name of the function that you want to call. And what we will notice here is this is a new type of function. All the other functions we've had just output something based on the input. What this will do is it doesn't output anything. It will actually change the thing that we called it with. Okay, so that's very important. And there are many cases of this. And there's one more thing I want to point out, which is that there is, in Python, there is a sense of inequality, okay? So you can use this sort of operator like in normal math, a less than or greater than or equal to. So, and how does this work? It uses those Boolean values, like we had said. So in this case, 4 is less than 5. That outputs the Boolean object true. Well, that is true. I mean, 4 is less than 5, so that's not a surprise. What if we wanted to say two things are equal to? Well, would we type it like this if we type it in? No, well, that's already taken. So as we saw, single equal sign is already taken for an action in Python. It assigns a variable. So we need to use double equal sign, as the error is telling us here. We need to use double equal sign. And this is false. No, 4 and 5 are not the same number. And there's all of these, all that you would normally expect. Less than, greater than, less. This is how you type less than or equal to. This is how you type greater than or equal to. Again, most of these things are down to limitations of having to type these on a typewriter style keyboard. You know, there's not on the keyboard, there's not a less than sign with the underline underneath to represent less than or equal to. So that's how it is. Okay, now we've seen a lot of different functions. We've seen functions which operate on variables, change objects in some way is what I mean. Or we've seen functions which, take in some input and give some output. Let's say we wanted to define our own function. This is something which we will often want to do. The way to do this in Python is to write def, the name of the function. So def is like define function. Def, let's say we want it to be make numbers. Okay, we've been going off this example here. And then we put in Python brackets. And then we put a colon. So what is this? This in here, these brackets, we want to put the arguments which are going to be passed to the function. In this case, let's say it's A, B, and C, okay? What are A, B, and C? A, B, and C are to be defined when the function is called, so we'll see that in a moment. Then, let's say we wanted to make a list, numbers, which is equal to this thing right here, ABC. Notice here, I'm just adding spaces. You can just add spaces wherever you want in Python and it won't yell at you. And then you will return numbers. So what does this return statement mean? So the way we define a function in Python, we give the name of the function, we tell what we want to call, or what we want the function object to be when it's called, and then we're going to output something. So a function in Python, it takes in some inputs and it gives out some outputs. Now we can also write a function to just operate on whatever is passed into it, like we had seen with the .append function here. But that is still called the same way. So all user-defined functions are called in this way. So let's run this. And now, if we write our function, just in the same way as we had done, at the beginning of this, the type function, okay, make numbers, and let's say we want A to be 1, and now, in a break from tradition, B to be 3, and C to be 2. So we're just going to type it like this, 1, 3, 2. And then pressing the enter sign, it'll output the list, which we would normally would be numbers in this case, and that makes sense. So this is pretty good. We can make our own functions, and now with these extra tools, with the Boolean operators like the less than and equal to, and the equals sign, and all of this, the slicing, we have a lot of tools here. We're much more capable of operating on and working with different object types. But, okay, let's say we wanted to now actually do something with our Python program and not just demonstrate the syntax, just show how we can type in things. Well, as I said, so far, all we have is essentially a fancy calculator. But let's say we wanted to actually write a program which can make a decision, take some input and then do something with what we give it, other than just, multiply a number together automatically. So what we're going to see here is that there's two more tools. There's something called a if statement, which allows us to, the first of these is an if statement. Okay, so this allows us to look at some condition, and if that condition is true, we will execute a section of code. Otherwise, we will not run the code. Sorry, that is to say we will not run a certain section of the code, okay? So how do we do that? Let's say in our Python, in our script here. Now you can do this in the console, but it's a little easier to show in the script because this is like the defining functions. The if statement is mostly a multi-line sort of a style. Now this is all very Python is sort of, it likes you to write things in a certain way. So we have to do it like with where we defined the function and then we wrote this colon, which kind of indicated that we were going to start a line or start a program, and then we had the index, or we had the tabs here. So the tabs sort of indicate that we are now in this sort of different area of the code. Now, the IDE did it automatically before, but it's a little less clear. It's a little more useful to understand what that means when we're talking about the if statements. So let's say we wanted to say some variable, right? We're going to assign a variable Boolean, okay? And we're going to assign it the true, like we said before. Now, essentially what we want to do, like intuitively with this Python program, if some condition is true, if Boolean is true, then we want to run, and so we're typing colon here, and then we're going into the enter to type a new section of code, okay? If Boolean is true, then this section of code will run, this section here, in the indent. And now, let's say we wanted to type, let's do this actually, let's do this before. If Boolean, we're going to print, see, we're starting to put a lot of pieces together here. 1, 2, 3. Okay, so we are in our, perhaps this is a little confusing, so we're just going to, let's say, make numbers 1, 2, 3. We're going to make a list numbers 1, 2, 3, and we're going to assign it to a variable called LST. And then we're going to print that variable. This is if Boolean is true. But notice, I set Boolean equals true, so it's going to be true, and this is going to run. Now this is pretty good. This is easy to understand. But let's say we had Boolean was false. What would happen now? It's easy to understand. This section won't be run because our if condition was false. Okay? So what is really going on here is that our if condition is looking at whatever is after the if and before the colon. If that thing evaluates to a true object, so we could use, for example, 4 is less than 5. If 4 is less than 5, we're going to run make numbers, and we print the list. Here we go. Whatever is in here, if it's true, if runs. If it's not true, if doesn't run. And if runs, whatever code is after the if that code is indented, then it will be run. Okay. So, what happens if we were to put a different section of code after that, which isn't indented? Let's say I wanted to print again, my name is Marty. Okay. In this case, my name is Marty was printed. That's not too surprising. Let's say our if condition, we set it back to Boolean. Now in this case, we know the if will not run, but my name is Marty is still printed. So as expected, the things that aren't in the indentation section are not run. Okay. This is all well and good. This is all very easy to understand, I think. Of course I think it, but I hope you agree. Let's say I wanted to have another if statement which had a different condition, but that I knew that these two things would never be the case. Let's say I didn't know what Boolean was, and so let's say Boolean, let's say instead I had some number, let's say Boolean was a number, 6. If Boolean is less than 5, these things will run. Well, that is not the case. So then we're going to type a different, in this example here, this is just something you can do. We're going to type a different type of if statement called an else if statement. So this, the computer will only check the else if statement if didn't run. If runs here, then this won't get evaluated. In this case, let's say is Boolean greater than 5. And then in this case, we're going to want to do those. But let's say we have only 2 items in the list instead. What happens? Why is it yelling at me? Make numbers. Oh, because it needs 3 arguments. Okay, you can see here. So our function lists 3 arguments required. It needs 3 arguments to be passed. So instead, let's say 1, 3, 4, or 1, 2, 4. Okay. And now 1, 2, 4 is run. So you can see the elif here statement, that works. Okay. So one more thing we can do. I've written here an else. So let's say we had a whole series of if and else if statements. And we go through and none of them pass, none of them run. Whatever we put then in the else statement will be run. Okay? So let's say Boolean was 5. In this case, neither of these 2 would run. And in this case, we want to print the classic hello world. Well, we can understand very predictably hello world will pass, and it will run. Because Boolean is 5, so Boolean isn't less than 5 and it's not greater than 5. So these 2 will not run, and else will always be run if it is put after any other set of if statements, including if there's only one. This will also call hello world. So we don't need, when we do else, we don't need to specify any Boolean condition. It will always run as long as the previous if statements weren't run. Okay, so that's the real utility here. So, this is all good. There's another little tool here. So let's say I wanted to operate on a Boolean like I did with the operating on the numbers. So we can flip a Boolean operator. If we print not true, we will print false. So what does this mean? If we have some, let's do it like this. Okay. If we have some Boolean variable, or a variable which refers to a Boolean object, and then we want to we put not before it, whatever the Boolean is will be flipped. Okay, so that's understandable. Oh, whoops, I don't want to save this. And false is printed. Let's say instead I had 2 Boolean operators, or Boolean variables. And this could be, of course, this doesn't have to be a variable you assign. It could just be 4 is less than 5, or it could be some other object is less than this other object. Let's say we had bool 2 was false. Similar to the AND operator on Booleans, we have similar to the not operator, we have the AND operator. So if bool 1 and bool 2 are true, bool 1 and bool 2 will be true. The advantage of these is that they're really basically just whatever it would be in natural language. So in this case, bool 1 and bool 2 aren't true because bool 2 is false, and so this will be evaluated false. If we make this OR, this is another one we can use. Bool 1 or bool 2. Now, one of these is true, so the whole thing is true. Now, these are all very useful to know. Again, this all seems kind of weird. I understand, like, the first time you're using this, it doesn't really make sense. Why is this going to be useful? But we'll see in the second part of the workshop that all of these little pieces get used when we want to work with more advanced types of functions, okay? Because there's, we've worked with functions out here. Oh, big whoop, a function can tell us how long a list is, or, a function can tell us the absolute value of a number. It's like, that's okay, that's good and all, but what are we gonna, how are we gonna get to the moon with this stuff? Like, how are we gonna solve the Schrodinger equation, with this? Well, because we're gonna see, those two are obviously dumb examples, but we're gonna see that there are functions which can be used here to give much more advanced operations. And these little pieces, the knots, the ors, the dot appends, all these little things that you have to know to use Python, these will be made of great use in the next workshop when we start dealing with these more advanced operators. Now, these pieces in particular might not be used. I don't know, I don't remember off the top of my head, but in general, it's very useful to know. There's all these little pieces that are used to kind of fully express whatever you want to do in the Python language. And, it might be difficult to put it all together. So I'm just listing it, I'm just presenting it all here so that there's, it's easy to understand. Okay, so that's pretty much how you do if statements. So now we understand, we know how to represent objects. We know how to we know how to represent objects, and so essentially we can represent data in Python, whether that's a number, whether it's something that's storing a bunch of numbers, or whether it's like a word, right? Okay, so this is all good. We can save those objects and refer to them later. We can do operations with those objects. So as of item number 3, we essentially have a very advanced calculator. And now we can evaluate whether sections of our code will run or not, based on a true or false condition. And as we said, a true or false condition is one of these types of objects which we can operate on using these tools which I've described. Okay? So, that's all very good to understand. But as of now, so this is all very good. And in theory, right, everything we might want to do in Python, from a physicist's perspective, pretty much everything we would want to do in Python, we can do with these 4 pieces. But we're going to see like a little bit of an easier way to do this, because every command we want to type now, every command we want to give to the computer, we have to write a line of code for that command. And this is all good, in the normal case, when we're just or not in the normal case, but in the cases we've been describing so far, where we're just, it's like 4 or 5 lines of code. But it comes to a point, when you're like using Python to solve a differential equation or something, or using Python to like represent the temperature at each point in a metal rod, this is an example of something you might want to do, to store the temperature at each point in a metal rod, over a certain number of time. You're going to have so many numbers, and if you want to operate on like each element in your list, each little thing, each piece of data, you're going to have to write a line of code for that. And you could end up having to write hundreds of lines of code just to do something really simple. Well, instead, what we can do is we can tell the computer to essentially do a loop. So we can tell the computer to do the same repetitive thing over and over again. So there's 2 very easy ways to do this, okay? The first way, well, I shouldn't say very easy. The first way is very easy. The second way is a little odd, but it's good to point out. So the most important way, the common way to do a loop in Python is what's called a for loop. So we type for, and now we're going to use the exact same syntax as we used for all these other pieces here, for defining functions and for writing an if statement. So we're going to write for, and then there's going to be something, and then there's going to be a colon. Now in the case of a for loop, so I would just say, so this right here is going to tell us, and then we go into indent, and everything in the indented section of code will be looped over. So essentially, every time we do one iteration of the loop, we're going to run this indented block of code. Now so let's say, before we even write what we're going to be looping, what is the loop? Let's say we wanted to print, let's say we wanted to print hello world. Bit of a dumb example, but you know, maybe you really like that line. Maybe you really like that string. You want to just fill your command with it, fill your console. Now what are we actually going to loop over here? So we're going to write, in this case, the way to tell the computer to loop with a for loop, is we're going to write for some variable 1, in variable 2. Okay, so I'm writing this in a very general form here. Why is this yelling at me? Undefined name for variable 2. Oh yes, right. Well, I know that already. So of course I haven't set anything for variable 1 or variable 2. So if I tell the computer to, and I haven't explained what does this mean, but like what does this mean right now? What is this red dot saying? Like it's going to yell at us because it doesn't know what variable 1 and variable 2 are. So this is the structure of a for loop, is what I will now explain. So a for loop, it looks for individual elements in some object which has a number of elements, okay? So let's say we have for element in list, LST. If you type list, it thinks you're referring, the reason I'm just typing LST is if you type list, it thinks you're referring to the list object, and you know, so it treats it slightly differently. It might be fine in this case, but the IDE does color it, so I like to stay away, just for clarity. So what does this mean? Now notice here, it didn't, by the way, say anything bad about variable 2, or sorry, variable 1 being undefined. So if you look at it here, it doesn't care that element is undefined. It only cares that list is undefined. So let's say we did write make numbers, okay, 1, 2, 3. Now, as we've seen many times, list, LST in this case, will refer to the list containing 1, 2, 3. Now, what will this for loop do? For some thing, like whatever's put here in the for loop, whatever's put after the in, if it's an object which has, like we looked at with the len function, if it's an object which has a sense of, you know, containing multiple elements, what this loop will do is it'll loop through, it'll run once for every element in that object, and it'll, for each element in order, it'll assign this variable to that element. So what does that mean? Like, as we know now, list is a list containing 1, 2, 3. We want to print element. 1, 2, and 3 will be printed. Now notice, by the way, just to point out here, each time we write each time we run the print command, it'll print a new line. That's something nice it does, just to keep things differentiated. It would be pretty annoying if, you know, we'd have to type a new line every time. Oh, by the way, maybe this is useful to know. I don't know. It's probably a little bit minor at this point, but the way to type a new line is a \n. So if we did this, this is another little piece that's good to know, but not essential. There's a space between hello world and our numbers. The \n here just prints like an empty line, essentially. And you can put the \n into with other strings. So if we did \n hello world, it still works, essentially. It even considers the space part of the string, which we didn't want to do, but whatever. Okay, I'm getting sidetracked. So the important part here is that this for loop is going to loop through every element in the list. It's going to loop through every element in the list, assign that element to whatever variable we have here, and then we can do something with that variable. Let's say we wanted to add 1 to every element in list, okay? Well, we've done this before, right? We have a plus equals to 1, remember? We have that special way of writing it. Essentially, we're writing we're assigning variable will be set to whatever the current value of variable is plus 1. So, this makes sense, right? So we're going to loop through a list. We're going to look at each element. We're going to add 1 to that element. Okay. And, we're not putting anything out to the console here, so nothing's going to happen in the console. But if we look at list, we can think now each element will be increased by 1. Okay, but that doesn't happen. So what's happening here? So what's actually going on when we run a for loop? And this is weird. This is deceptive, and this is also, I said earlier, 60% of the bugs is that you don't understand what object you're working with. Probably another, I don't know, this is less common, but probably another 10% of the bugs, maybe like 5% of the bugs, is not understanding how your for loop works. So what your for loop is doing here is it's not actually variable isn't like that element in the list. It's not saying variable is that element in the list. It's just saying, okay, that element in the list is some piece in memory, something in memory, okay? But we want to assign this variable to that piece of memory. But when we do this assignment statement here, what we're doing is we're just assigning variable to a new memory. We're not changing the memory that it originally referred to. So let's say we actually wanted to do this. Let's say we wanted to write a for loop which correctly just adds numbers. So what we're going to use here is something called the range command. Now the range command takes in a number. Now there's other ways to call it, but the most basic way to call the range command is just to do this. And now what does it spit out here? Range 0, 5. So, what does this mean? Now, range is a special object type, which has this, it's not really used in any purpose except for in for loops. But range is a special object type, which allows you to iterate over every number, starting at the beginning and going until, in this case, up to the end number, but not including the end number. So if we go back, and if we go for variable in range 5, and then we go print variable, so even though this is just essentially a number, the range command allows us to loop over all the numbers up to that one, including 0, and so this for loop here will print all those numbers. Now in itself, this is not very useful, but let's say we wanted to loop over, okay, there's 3 elements in list. So for variable in range 3. And now, this is kind of cool. We're going to use our special indexing earlier, and we're going to refer of list. We're going to go to list, and we're going to pick out a certain element of list at whatever index, and then we're going to assign it to some number. In this case, we're going to add 1 to that element, okay? And when we do this, what's going to happen? Oh, I keep pressing the button to save. What's going to happen when we press that, when we do this, is that this thing will execute for variable 0, 1, 2. And notice, because there are 3 elements in list, it will have, each of its elements can be referred to with indices 0, 1, and 2. And then the items in list at each of those indices are going to be incremented by 1. And if we now put into the console, we can see that list has been incremented. So why is it that when we refer to the the list at an index, the element, when we refer to a specific element of a list, and then we reassign that element, it can be changed, but not when we, just refer to the item directly. This has to do with how Python is, manipulating these pieces of memory under the hood. And if you ever get really stuck when you're doing a program and it's something related to this, I would encourage you to dig a little deeper and to read more about how Python is, working with this memory, and it may work to solve your issue. And there's one more thing I want to point out here. So so we're going to add a comment here. We're going to comment out make numbers. Notice before, now everything past this comment, Python's going to ignore. And instead, we're going to make list refer to a string. Oh, but let's for this example make it a string of numbers. 1, 2, 3. Oh, I can have, yeah. Okay. And now what we would expect, based on what we've done so far, is that we would get back list, each element in the list would be incremented by 1, and we would get back a string 2, 3, 4. But we get an error in this case, because what we see is that strings can't be changed by referring to their indices, but lists can. So this is another thing about objects, which has to do with how Python, saves these things in memory. Essentially, certain object types can be changed without just creating a new object completely. Lists can be changed in this way. There's some other object types which we'll see later, which can be changed in this way. But strings, integers, floats cannot be changed. If you're gonna if you want a new string, you just have to make one completely from scratch. You can't change one that already exists. So this is something that's very important to understand if you're going to be looping over an some like list, some object with a sense of containing number of elements. It's very good to understand this when you're writing these sorts of programs, because it's a source of failure, really. It's something that can go wrong. So this is well understood. So just to recap, a for loop. Oh, and there is one other thing here. So just one nifty trick before I go on to the next thing and before I recap. So if we wanted to make it so that, let's say this was len, like let's say we wanted to make it so that this will always work for any list we pass to the LST function. For any list, it will just increment by 1, okay? So let's just say len of list. And now, because of how range works, this will just make a number of integers starting at 0 and going up to 1 less than the length of the list. And basically by construction, this makes the for loop refer to, every element in the list in terms of its index. And so now, as long as we passed any number, even some of them could be floats, because as we walked over before, we can add numbers to floats. So let's say this was just not related to our make numbers command, but from before, 5.5, 5, and 2, okay. Keep saving. 5.5, 5, and 2. And then we run tuple. Oh, shoot. Sorry. Don't worry about that. I should have used square brackets. Tuple is something else. Tuple uses the angle brackets. Okay, it ran, and then if we type list, it added 1. So that worked regardless, even though we didn't specify 3 in here. And if we do it again with 4, it'll work still. Now, let's say we had done it like this, but we had instead still said 3. In this case, only the first 3 elements will be incremented. Let's say we had just made a list with length 2. In this case, we're going to be indexing at element 2, or sorry, at index 2, which doesn't exist in this list. So using this range len scheme for iterating over a list with a for loop is very useful because it is independent of the length of the list. And it allows you to refer to each element in the list in a way that you can change the value if you want to. Okay, so we only have 6 minutes left here until we lose our booking of this room. So I just want to go over one more thing, which is a while loop. So this is the other way to do a loop in Python. So while loops are kind of tricky. So they work with Boolean objects, like we've been talking about. They use the exact same syntax, while something, colon, anything in this indented block after the while loop will be run for each iteration. How does the iterations work? I'll explain in a moment. But let's just say, for now, while print hello world. Okay. So, as I said, a while loop works off of a Boolean value. Let's just, as a test here, say Boolean equals true. Okay. So it's essentially the exact same format as an if. You just do while and then the Boolean condition. And now what will happen here is that when the code encounters this while loop, it'll look at the Boolean condition, and exactly the same as in an if statement, which also means, by the way, that those ands and ors and nots that I was referring to before, those also work here. They can be used here. It'll look at the Boolean condition, and if the Boolean condition is true, it'll run the loop. If the Boolean condition is not true, it won't run the loop. But here's the kicker, okay? It does this every time you run the loop. So it'll encounter this, it'll say, while Boolean is true, if Boolean is true, it'll run all of this. It'll go back to the beginning, and it'll look again, is Boolean true? If it is, it'll run all of this, and then it'll go back to the beginning. So it's easy to see here that in this case, I've written an infinite loop. And it's very easy to write infinite loops where using while loops in Python. So there's not much to do. You know, I mean, you can't really, this is a very simple one, but if you're writing a complicated program, you might not realize before you test the code whether it'll be true or not. So it's really tough to tell. And it's often safer just to use a for loop if you can. It's not applicable to every problem. So, in this case, Boolean is never changed, right? So it'll run every time because Boolean is always true, and it'll never stop. If it were ever the case that Boolean were false, if it ever something happened in the block of the loop that caused Boolean to be false, let's say this is one thing we could do, we just set Boolean equal false on the first one, right? Or just as soon as the loop is run, Boolean equals false. Then we get to the beginning, Boolean will be false, and once the while loop fails to run, it won't run, and it'll move on to whatever's next in the code. Okay, so, and then let's say finished while loop. So in this case, hello world, what's happening here? Let's trace the code. So it's going Boolean equals true. It's going while Boolean. Okay, while Boolean is true. Well, Boolean is true, so we're going to go, at least this one. Python doesn't know it's about to get killed off. It prints hello world. And then, now we're setting Boolean as false. Now remember, like I said before, we're not changing this element in the memory. There is still some piece of memory sitting around which says just a true object. We're just reassigning the variable Boolean to refer to this new object, false. And now we go back to the beginning of the while loop, and we look at Boolean, and it's false now, and then we go to the end. As soon as we get a false while, we kick out of the loop, and then we go and run the rest of the code and print finished while loop. Let's say I didn't have this happen. We're never going to get to finished while loop, and my computer is going to blow up. Now you can see here, this is still running, right? The code hasn't finished running yet. It's just printing infinite numbers of hello world. And you know, if I wanted, I could just leave this thing running, and it wouldn't. I mean, eventually, I think Spider kills it, the IDE. Eventually, my computer would die. Actually, I have it plugged in, so eventually the hardware would burn out if we didn't have that limitation. This will never stop. So it's good to be wary of while loops for this reason, but sometimes they're necessary. So I'd like to leave you with one exercise, and then we'll leave. And you can message me on the Discord, and we can discuss the way to accomplish this. But I've printed it here in the console. I think it's an interesting practice to to work with some while loops in case you ever need to do it, just to make sure you're not going to write yourself into an infinite loop too many times. Write a user-defined function which uses a while loop to start at a given integer, let's say 3,000,004, and print all even integers less than or equal to this number. Hint, use the mod / / operator. Okay, and so that's a good operator to use in this case. As I said when it was introduced in this workshop, it's very useful to detect the presence of even numbers. So I'll say just so. One thing that you can do here is this also can be used with the == sign. So let's say we had 5 mod 2. If that is equal to 1, wait. Yes, so 5 mod 2, that is 5 divided by 2, rounded, that is 2.5, rounded down to the nearest. Oh, I think is that a fire alarm? No?
No.
Didn't sound like it. Well, it's a weird school alarm though, eh? Anyways, don't worry about it. Okay, so yeah, this will be 2.5 rounded down. So if the number is, so I think the way to do it is, I guess it's a little odd actually. So for some number, like let's say our num is 4, and then num, so you do num, oh, I didn't say it because I think it's kind of, I forgot. It's just the same as in regular math, but you can use these parentheses to do bedmass operations with your code, and then it just evaluates your code in math, on a certain order. So num -1 mod 2, that'll be 1, whereas if num was, so if num -1 mod 2 is 1, if this is 1, it'll send true if num is even. It'll print false if num is odd. And, oh wait, sorry. No, that's not what I put. I wanted to do num = 5. Yes, but what I said is true. So you can use this to write that function. And then there's one more exercise I had thought of, which is here. I'll just change what I'm looking at here. This is one more exercise which I had thought would be good to work on, but we didn't get time to because we started late. Right here. This part here, exercise. Use if statements to write the mathematical function, this thing right here with the cases. So it's going to be like x squared growing hyperbolically, or not parabolically, when x is positive, and 0 when x is negative, as a user-defined function that takes one argument x. And so we can use the special. So notice I have this here. This was before I meant to use this before I talked about loops. So you only need to use if. So this is a pretty easy application of the if-else scheme for writing code. Oh, here, just to get it on the screen. This part here. Okay, so that's all from today. So make sure to attend the next workshop. Let me see, do I have any messages in the chat? No. So make sure to attend the next workshop. It'll be 1 week from today at 5:30 p.m. We will start a little, well, we had some people say today that maybe we should have the drinks and snacks after. I'm not sure. Maybe we'll do that. So we might not start late today, or no, next week, I mean.